Hello and welcome to this webinar. It's great to have so many of you attending today, so thank you very much for joining. Just a quick introduction. My name is Stuart Scott. I'm the content lead here at Cloud Academy, and I have the pleasure of welcoming two guests with me here today. Firstly, I'd like to introduce Jigar Shah, who is a product line manager from Palo Alto Networks, and he has over 8 years' experience in managing mature products and disruptive technologies. We also have Sam Gardesham, a product manager and technology evangelist from Aviatrix Systems, and he is focused on private and public cloud network and security products. So welcome to you both, and thanks for being here. Now, the focus of today's webinar is centralized around network security within AWS and how you can integrate Palo Alto Networks VM series next generation firewall and its capabilities with AWS Transit Gateway. So we'll look at the benefits and enhancements that this can bring to securing your environment. Now, before I hand over to Jigar to begin the slides, I just want to remind everyone that questions can be submitted during the webinar using the chat feature, and there will be a Q&A session at the end where hopefully we can get through a lot of these questions. And also, just to let you know, this webinar is being recorded, so everyone who has registered will be sent, a copy will be sent out to everyone in the next day or so. So over to you, Jigar.
All right, great. Thanks, Stuart. So what we're going to talk about is primarily how a next-gen firewall will provide protection in all the traffic that traverses your VPC. This is essentially following the shared security model that's laid down by AWS. Once a packet hits your VPC, it's the customer's responsibility to make sure that attackers are blocked and outbound traffic is protected, and you have to decide how you're going to do east-west. So that's the virtual firewall VM series doing inline. You can also learn about how an API-based solution like Redlock can make sure that your AWS environment is compliant with your security needs and is being continuously monitored for common security pitfalls. And then finally, if you are concerned about zero-day and exploits on your Linux workloads in AWS, you can consider using Traps, which is focused on protecting the workloads, and you can embed it as an agent or deploy it as part of your normal bootstrap process. So we are going to now go drill down on VM series and see what use cases and problems it helps solve over and above the basic security features that AWS provides as complementary capabilities. So here are the primary use cases on how the product gets deployed. The first one is as a gateway, meaning it's a perimeter firewall that's protecting traffic coming in and traffic leaving your VPC, right? So that's usually protection against exfiltration attempts, things like that. Then you have segmentation, meaning you're trying to do application level protection and segmentation, not just pure network policy segmentation. So the goal is when you have traffic connecting between different VPCs, different trust islands, or between different subnets inside a VPC, right? Then comes the use case for most enterprises, which is hybrid, on-prem data centers connecting into AWS. How do you make sure that the firewall makes sure that the right people can access the right resources, right? So this is the classic hybrid cloud use story. And finally, it is also possible that the virtual firewall gets used as a VPN gateway that you run in the cloud. Off late, we've offered obviously a service called Global Protect Cloud Service that helps you onboard branch and mobile users. So that's another way to do it. But the focus of this presentation and conversation today is how do you protect the traffic that is going in and out of VPCs and make sure the right protections are enabled. So let's go into a little bit more detail on these use cases. Okay, so for internet-facing applications, this is your classic AWS perimeter security need. And let's say you're hosting a big web application internet-facing. For example, if you run on Apache Struts as your web application and there's a vulnerability, we're obviously there to protect against that. This is the usual IDS IPS use case, right? And that's going to give you those perimeter security protections until you have time to go update it. The next more important one for a lot of customers is the outbound protection against exfiltration. So you're able to now write a very secure and specific policy. For example, The firewall can get information about all your instances, the tags and metadata, so you know what all your Ubuntu servers are, whether they're production or not, and then allow apt get, for example, to specific URLs, things like that, right? This is application whitelisting by destination, so that you can avoid traffic to, for example, command control servers or Bitcoin mining, outbound. I think hybrid cloud, we talked about it a little bit. This is kind of fairly obvious. The use case of app ID and user ID can really nicely combine in the cloud example. So you can make sure that you don't have lateral attacks moving between on-prem and cloud and vice versa, right? Okay, let's go to the next one. And the last one is sort of that segmentation, but at an application level, so that you're preventing attacks and threats from moving east-west between VPCs and inside. So this is the normal whitelisting of applications that you would go through to make sure that attacks are not spreading across your infrastructure. So having said that, now let's go into how you would actually practically deploy these use cases from a deployment perspective. So let's go to the next one. So this is the internet-facing architecture. This is an auto-scaling stack where you have a front-end tier of firewalls deployed behind AWS load balancers. And this is an auto-scaling group based on the metrics of the firewall. So it leverages the ASG functionality, and then it scales based on demand. And behind it, in the different VPCs are the separate applications that are connected over private link or VPC peering. And this gives you that full scalability for internet-facing workloads. Now, for the rest of the use cases, the outbound, the east-west, and hybrid, a common architecture is to use a transit or a standardized shared security VPC. It's also often now called as the hub in a hub and spoke model. So in that model, you would have the left side where in this diagram where you have lots of VPCs that need outbound or east-west security. And the right side is the VPC where all the firewalls would live. So you have several choices in how you construct it. You can build a transit VPC based architecture where you lay out several of them and then connect them to the central VPC. A recent option that Amazon introduced is called Transit Gateway, where Amazon provides this construct that allows all these three set of systems to connect. And this should have ideally allowed all the VPCs on the left side that need security to connect to the firewall stack on the right side. But as you can see in the slide up here, we notice that there are several limitations when you want to go beyond a small scale deployment. So the first is that every time you add a new VPC, you have to make a manual change in the route tables in the transit gateway so that you can decide which VPCs can talk to each other. Second is that the firewall has pretty high performance, so we can do up to 6 gig of app ID and 4+ gig of threat prevention in the VM series firewall on AWS. You can look at the data sheet on the website to see the exact numbers by instance type. But to hit that additional scale, when you deploy multiple instances on the right side for the firewalls, if you want to use several instances, you are forced by design that there is an IPSec tunnel that is set up between the transit gateway and the VPCs of the security stack. And that means that you get limited to about 1 gig of performance per IPSec tunnel. And that means that obviously you're not using the full capacity of the firewall. And the third one is that as you add more firewalls, or even with the basic stack, you do require a source NAT to be done in the firewall. This is to make sure that the return traffic does come back to the same firewall for security inspection. And that's probably not ideal because you want to make sure that source and destination can see each other directly and that the firewall is more transparently inserted. So these are sort of some of the reasons why when you get to beyond a small scale, a different solution's needed. And that's why we've partnered and talked to Aviatrix, and they're going to lead through the solution they've built around us.
Great. Thank you very much, Jigar. That was a good background on the Palo Alto Networks VM series. My name is Rod Stellmuller. I'm actually joining the webinar to do a few slides to lead up to the solutions that we have here. But I wanted to bring out a few things. We actually do a lot more than just the firewall network that we're talking about today. We do a lot with transit networks, multi-cloud networks, enterprise cloud backbone, as well as high-performance encryption and intelligent visibility. We won't be talking about all of these things today, but I think it's important to understand that there's a bigger picture here. One of the things that we talked about here was deploying within an AWS TGW environment. And this is one of the first things that we do is we actually utilize our intelligent orchestration and control to deploy the AWS infrastructure and propagate all the routes out to VPCs. This is before you even bring in the firewall into the picture. But today we're going to talk about bringing next generation firewalls, bringing the Palo Alto Networks VM series into this architecture, and how our controller actually simplifies the deployment of this by propagating routes out to the firewalls as well as into TGW and into the different VPCs, providing extra capabilities like multi-region, multi-account, some of the things that aren't offered by the native AWS constructs. So just to give you an idea of how this gets deployed and how easy it is, I'm just going to walk through how these components get deployed, and this will actually be very much what the demo that we show here towards the end will actually demonstrate how easy this is. But basically, the first thing you're going to do is spin up the Aviatrix controller. And this is simply an EC2 instance that you spin up the controller. This is essentially the brain of the orchestration and the ongoing management of everything. So the controller would then start by actually spinning up the TGW and establishing the routes and the route tables to the different VPCs that you're going to want to protect with the Palo Alto Networks VM series firewalls. The second thing that it does is it spins up the Firewall Network VPC. So this is a VPC that will be specifically used for the firewall network and to build the infrastructure to support the VM series firewalls. The next thing is to spin up our gateway, and this gateway can be, I'm not representing in this picture, but it's typically high availability with 2 gateways running at the same time. But you saw that the first thing that happens there is that the routes get propagated from TGW into our gateway there. So the gateway now is knowledgeable about all the routes to the different VPCs. The next thing we're going to do is we're going to fire up the VM series firewalls and propagate the routes to them as well. So now the everything within the Firewall Network VPC is aware of the routes that are actually available in the VPCs that are running in the AWS infrastructure. The next thing would be to actually apply the rules into the VM series firewalls using Panorama. So of course, you could spin these up and have the rule set to be deny all, so that no traffic is going to flow through things until you're ready to go. Or you could wait to make the connection to the Firewall Network VPC, which is what I'm demonstrating in this case. So now Panorama will push the policies and the rules that you want applied in those VM series firewalls. And then the last thing is to connect the TGW to the Firewall Network VPC. And at this point, you're ready to flow traffic into the VM series firewalls for inspection. And all of this happens within 45 minutes. So most of the clicks are very quick. Sometimes you have to wait for an instance to spin up, and this is what makes it take 45 minutes. But you can see how easy it is, how the routes get propagated for you. Lots of orchestration that's happening. It makes it very easy to install this entire infrastructure. Then you have essentially an infrastructure set up where you have, let's call it VPC A, B, and C here, where you have a rule that says A should be able to talk to C. Of course, when traffic leaves A, it will be then looked at by the VM series firewall, and if it passes, it will be delivered to C. You may also have a rule that says that A shouldn't be able to talk to B, and of course, in this case, that same traffic would be routed for inspection at the VM series firewall, and in this case, it would be blocked. So this is a simple view of what this does, but it gives you an idea of how simple it is to spin this up and get everything configured and ready to go. I'm now going to turn over the presentation to Sam, who's going to go into some of the details about how we gain performance and how we gain scale without having to deploy SNAT and lose some of the visibility. And then he will walk through a few other things, and then we'll do a demo.
Okay, thank you, Rod. Appreciate that. All right, so let's talk about how Aviatrix Firewall Network solution makes for a superior solution to alternative options for integrating your next generation firewall in AWS Transit Gateway. Well, first and foremost, performance is something that is always on top of the mind when you're trying to insert a third-party appliance that will be doing traffic inspection on your application traffic. You want to make sure you get the best performance, lowest latency, and you also want to make sure the compute resources that you're basically paying for are spent on the application that you're specifically targeting. So today, the available options for using, let's say, a next generation firewall such as VM series would be to use IPSec tunnels. Now, AWS Transit Gateway allows you to do IPSec plus BGP and do ECMP for scaling. But what is the problem with that? So the obvious problem number one is that IPSec tunnel inherently has performance limitations. Secondly, you're basically using firewall's resources on IPSec tunneling as well as decryption and encryption of traffic. Now, that limits your throughput per instance. So what that means is that you're not really getting the most out of the firewall and out of each instance of the firewall. So Aviatrix solution uses native transit gateway attachments in order to scale to the throughput that the transit gateway supports. We're talking about the scale where you can get up to 6 gigabits of traffic out of each VM series instance, as opposed to a fraction of that when you're using IPSec, right? And then the other problem with using the available methods today, such as IPSec and ECMP, is that you have to SNAT traffic at the firewall. What that means is that you're going to lose visibility into source of traffic because you cannot preserve the source IP address of traffic. This is to ensure session stickiness and make sure the return traffic on a specific flow comes back on the same firewall. With Aviatrix, since we are managing load balancing of traffic with Aviatrix gateways, there is no need for SNAT. So therefore, there is no trade-off for getting scale and performance that you need with your next generation firewalls. Now, a common question that comes up when we talk about the solution is that how do you do scale? How do you manage session stickiness? How do Aviatrix gateways actually load balance across different firewalls? So Aviatrix Firewall Network, first of all, has two important components. Number one is the Aviatrix controller, which orchestrates various elements such as AWS Transit Gateway route table propagations, VPC route table propagations, and then Aviatrix gateways that manage the session and load balancing across the firewall. And this solution offers what we call inactive mode. Basically, you can have as many firewalls in active mode as you want. So you don't have to have a firewall that's sitting there basically idly just as a backup. You're paying for the license, you're paying for the resources of EC2 instances, and the firewall is actually not doing anything. With this model, all of your firewalls are active. So how do we manage that? Let's just assume that we have two flows, right, between two different endpoints or two different sessions between the same endpoints. And the first session is hitting the firewall in the top right, and then the second is hitting the firewall in the bottom right. What happens if one of the firewalls fails? So Aviatrix gateways are monitoring the health of the firewall. And when they detect a failure of the firewall, they will rehash traffic to an available gateway. So This is how Aviatrix gateways basically are able to manage not only the session stickiness as well as the hashing of traffic, but they allow you to scale to multiple firewalls and also get high availability because you can deploy in 2 different availability zones at the same time. Now, with that, let's take a look at a recorded demo of how you set up Firewall Network through Aviatrix.
Okay, first let's take a look at what we are going to be building as part of this demo. We already have Aviatrix controller deployed and configured for our AWS account. We have also gone ahead and deployed an AWS transit gateway with some attachments in our account. We will begin by building a VPC where we're going to launch our gateways as well as the firewalls. Next, we will create the Firewall Network security domain, and we will launch Aviatrix gateways into the VPC in the appropriate availability zone and subnets. Then we will enable these gateways for firewall networking functionality and attach the VPC to AWS security domain. Lastly, we will build the firewalls and attach them to the gateways for forwarding and traffic inspection. We will be using the Firewall Network's step-by-step workflow as a guide for deploying the components that we just showed. As we can see, the first step here is to create a VPC. So let's go ahead and go to the useful tools and create a VPC right here from the controller. The fastest and easiest way to create a VPC is to use the VPC creator that comes with Aviatrix controller. After selecting the account name and the VPC region, we'll enter the VPC name and the IP CIDR block that we want to use. Lastly, we have to make sure that we select the appropriate use case for which we are creating this VPC. The controller will automate deployment of the VPC as well as required subnets for this particular use case. Okay, back to our diagram. We've created the VPC. Let's see what's the next step and continue forward. So the next step is to create a security domain for our firewall network. Let's go to the Transit Gateway Orchestrator, and under Plan Workflow, step number 2, we will find the appropriate function for creating a security domain. Okay, we need to make sure we pick the right transit gateway. We enter the security domain name. This can be any name, and then we select the firewall domain and click Create. Okay, so far we've created the Firewall Network VPC as well as its security domain. Let's move forward to the next step.
Back to Firewall Network Workflow, we see step number 4 is launching Aviatrix gateways for Firewall Network. To do that, we'll go to Transit Network and Setup. Okay, we'll enter required information to launch the gateway inside the Firewall Network VPC. When choosing the public subnet, we will basically pick the first public subnet in the first availability zone, and when we enable HA, we will pick the second availability zone. Note that you have the option to select the gateway size based on the performance desired. Aviatrix gateways support both C5 and C5N instance types, which enable the best possible networking performance on AWS platform. Okay, now I'm going to enable high availability, which basically deploys the second gateway, and I will select a public subnet that is in a different availability zone for high availability. Okay, at this point we have our Aviatrix gateways deployed. The next step here in the Firewall Network deployment is to enable the gateways for Firewall Network function. So in step 5, we choose the gateway and click Enable. That's done. Now let's go to step 6, which is attaching the Firewall Network VPC to AWS Transit Gateway and the appropriate security domain. All right, we've got the gateways deployed and ready to go. Using the advanced integration of Aviatrix with Palo Alto Networks VM series, we can actually launch the firewall from the controller itself. So in step 7A, we choose the gateway name, the firewall image based on our subscription level, and the management interface and egress interface for the firewall. Notice you have the option to attach the firewall right after launch. This basically means the firewall would be active and in line. So this option gives you the flexibility to choose whether you want a firewall to go active right after launch or you want to wait until policies are applied before firewall becomes active and in line. Okay, the first firewall is up. Now let's go ahead and launch the second firewall. Here I choose the gateway to be the HA gateway, which means the firewall will be launching in the second availability zone. And you have the choice of selecting which one or how many you want to attach to each
gateway. I went ahead and attached 2 more firewalls, so we ended up with 4 firewalls as we originally had intended. Let's take a quick look at a couple of other important functionalities here. Let's take a look at the Advanced tab. Here we see every firewall network deployment under this controller. We can also drill into each deployment to see status of each of the firewalls and perform detach and attach function, and also see the status of them being attached or detached. It's important to note that if you actually have no firewalls attached, traffic will be bypassed and it will go through the gateway from the source and destination. You also have the ability to turn traffic inspection on or off, or enable disable egress in this menu. Furthermore, you can see status of the Aviatrix gateways here and perform switchover in case of a failure. Now lastly, let's quickly take a look at how we can define traffic inspection policies or firewalling policies in the Aviatrix controller. This is done under Transit Gateway Orchestrator, step number 3. Basically, you choose your firewall network domain, and then anything that you decide to be connected to the firewall network domain will have to pass through the firewalls in order to be able to reach its destination.
Okay, so that concludes our demo. Now, before we move forward, I wanted to just recap what we talked about the advantages of using Aviatrix Firewall Network over alternative solutions based on what we learned from Rod, Jigar, and also the demo. So without Aviatrix, today you have to contend with a lot of different compromises, such as either losing performance per firewall or dealing with complexity of configuring route tables or BGP or IPSec tunneling issues, or if you choose to do ECMP that allows you to seemingly scale across multiple firewalls, then you have to SNAT traffic and lose visibility. With Aviatrix, you get best of all. You get the best performance out of each VM series. You don't have to deal with any IPSec configurations, no BGP configurations, and route tables are managed end to end. And there's no need to SNAT, so you get full visibility in the source of the application, and there will be no compatibility problems where this is an important factor. Now, as we saw in the demo, the solution does not just end with managing the firewall network. We're also managing AWS Transit Gateway route tables, allowing you to do network segmentation using the route tables that are provided by AWS Transit Gateway, as well as the VPC route table propagation. And with our advanced integration with Palo Alto VM series, we are also programming the firewalls for routing functions. All right, so that concludes our presentation. We're going to move forward to Q&A.
Great, thanks very much for that, guys. As a great demo, there's a lot of information in that. So whilst you guys have been talking, we've had a number of questions come in from the audience. So I'll just go through those now, and if you can guys can just jump in and answer them as you can. So starting with the first question. Does the integration of Aviatrix and Palo Alto Network require transit network, or can it be deployed without transit as well?
Yeah, that's a great question. I'll take that. You don't need transit. The firewall network, the way it works is that it's basically designed to work with any direction of traffic, which is east-west, VPC to VPC, VPC to egress, or VPC to on-premises. And if you don't have VPC to on-premises connection, that is fine. It will be able to inspect your traffic between VPCs, as well as sending traffic through the VM series for egress inspection.
Excellent. Thanks very much. Another question. Will auto-scaling for VM series work with Aviatrix?
So I think that's sort of a two-part thing, right? So today, the auto-scaling is for internet-facing workloads when it's directly coming into VM series. The current Aviatrix solution has what we like to call, let's say, managed scale. You know what capacity of the VM series firewalls you need, and you deploy that many from the Aviatrix controller. Auto-scaling into that stack is the next thing that we're discussing. And so if you have a use case, you should reach out to our sales reps, and then we can follow up and sort of show you what we're working on in that area. Sam, you want to comment anything on that?
No, yeah, you're accurate. You're absolutely accurate. And we're continuing and building on the feature sets for allowing the auto scaling in the upcoming releases and further integration with VM series that makes that even simpler than it is today.
Yeah, so exactly partly what Sam just said, right? Let's call it scratch the surface. We've done this initial integration. We're open to feedback and say what more can we help solve as problems.
Sure.
Excellent, thank you. Okay, we've got a few more questions. We have, does Aviatrix and Palo Alto Solutions work with automation tools like Terraform or CloudFormation?
Sure, I'll take that. Yes, our Aviatrix controller itself can be automated through Terraform. We have that integration as well. And if you have the controller spin up your firewalls or your VM series in this instance, you can also use Terraform to control that function through Aviatrix controller. We also have REST API support. As far as CloudFormation goes, CloudFormation is more for the AWS construct itself. So Terraform would be a more suitable solution after the first building blocks of this application is built.
So I think I'll add sort of something similar, right, to what Sam said. So if you want to see the automation tools that we provide for VM series, you can see them on live.paloaltonetworks.com/AWS. You'll see all the automation tools like CloudFormation templates and so on, including Terraform and a Terraform resource provider also. Generally speaking, once the deployment is done, in this case by Aviatrix, you can also use Python or Ansible to go and automate the firewall configuration. What you can also do is, as part of the deployment, make sure that the firewalls are attached to a Panorama device group, and then all security policy and management can happen from Panorama post-deployment. Because Aviatrix is doing the stitching of the network, and they're managing that easy flow of connectivity. But security policy, once you get to a certain scale, should get managed from Panorama. That way you're not dealing with individual firewalls that are essentially like cattle in this analogy of pet and cattle, that these are just cattle firewalls that are scaled out with the Aviatrix solution.
Yeah, thanks for that. Yeah, and Panorama integration here is extremely critical because while Aviatrix allows ease for scaling out, you need Panorama to come in and manage your policies across different firewalls. So let's move on to the next question.
Okay, next question. Someone's asked, why not just attach a security VPC to TGW instead of IPSec?
Yeah, that's a fantastic question there. Matter of fact, you can, but when you do that, then you cannot scale out. Then you're going to be pretty much having an active firewall and a backup. And the backup firewall, as I mentioned throughout my presentation, is going to basically be up, but not forwarding traffic. Where with Aviatrix solution, since we're using our gateways to kind of be the gatekeeper of the traffic, if you will, we can have all the firewalls in active mode and actually doing the work for you.
Excellent, thank you. We still have a few more questions if you guys are okay. Next question. Is the routing information propagated between the Aviatrix controller to the TGW and the Aviatrix gateway and the Palo Alto firewall via a dynamic routing protocol, or is it a static list?
Yeah, great question. I'll take that. So at Aviatrix, we believe in cloud native where it's possible. So in the cloud, what we are doing is we are basically propagating routes with the APIs of, say, AWS or APIs of VM series, right? There's no need to run any routing protocol between different elements of the architecture that we showed. And therefore, we make it a lot, performing faster, we reduce the overhead and make it a lot more simple. And our gateways specifically in this case are going to put every ounce of their compute power in making sure that the packets are forwarded as fast as possible and getting the best throughput possible out of those instances.
That really simplifies the whole thing, doesn't it?
Right.
Does this work with Direct Connect?
Yeah, absolutely. And it kind of ties back to a question about earlier. What if you had a connection to on-premises? In this case, Direct Connect or otherwise, you could definitely do that. Aviatrix controller can. It allows you to orchestrate Direct Connect into Transit Gateway, or you could do also VPNs. We could also use our own edge gateways for forming a tunnel to on-premises. We also have another solution that allows you to do high throughput encryption between your AWS Transit Gateway environment and your on-premises.
Excellent. We just got a couple more here now. Is 6 gigabits the max throughput, or is there any way to get more throughput out of this?
Yeah, so currently we're using for the VM series on AWS on the C5, M5 generation of instances, and 6 gig is the max app ID throughput we can achieve. We're always working to improve more, and if you have use cases for higher performance, you can always reach out to the Palo Alto Networks rep. In general, we would still recommend that you actually pick even a smaller size instance with, let's say, 2 or 4 gig or even lesser performance, because at that point you can do horizontal scale out and get better price for performance ratio, right? If you have a 6 gig firewall and you have lots of them, you probably have underutilization of capacity at that point, or potentially if you have 6 gig of traffic going through a single box, and for whatever reason, if that instance fails or the underlying AWS infrastructure has failure, then you're trying to have 6 gig of traffic converge really quickly. So the general recommendation is, since the integration solution has scale out, use small to medium sized instances and do horizontal scaling. That's just a better cloud native design.
Yeah, fantastic suggestion there, Jigar.
Great, thank you very much. Okay, we've got another question here. If no IPSec or nor source NAT is used, what do you use for transitive routing? GRE over VPC peering or something else?
Yeah, great question. So the idea is that we don't want to use any overlays, or we don't want to have to tunnel in any way, whether it's IPSec or GRE, because then you have the same problems. You don't have the crypto problems there, but you do have the problems with tunneling and limited throughput, etc. So with Transit Gateway, since Transit Gateway allows you to actually forward traffic with what they call VPC attachment, you can get up to 50 gigabits per second of throughput or of bursty throughput per VPC attachment, and we are leveraging that for connectivity between the Transit Gateway VPCs as well as with the firewall VPC. So how do we now in that flow make sure that the firewalls get the traffic without having to actually do GRE? That's where the gateways come in. The gateways are managing that session, so we eliminate having to have any sort of GRE or IPsec tunneling.
Great, thank you. Someone's looking for some more information on design here. So other than this presentation, are there any white papers or design documentation that kind of shows how this works?
Yeah, we have actually a lot on the website about this. We actually just put some new content there, as well as you can always go to docs.aviatrix.com, which actually has some very good technical information about how this works and some of the details on that. So yes, and then of course, if you guys have any questions, you can see the contact page up now. You can contact us via email, you can call us, or anywhere on our website, you'll see the little chat bot, and you can go right into there, and you'll probably be connected to one of our solution architects who can go into more detail with you.
Excellent, thank you very much. I think we've just got a couple more questions now, and then I think that's the end. With Transit Gateway, you can use VPC attachments to send traffic to the firewall, and you don't have to use IPsec. What does this solution really add in addition to that?
Yeah, good one. I think that we kind of alluded to that earlier. There was another similar question. Just basically the idea is that when you do that, you don't get active firewall model.
Okay. And the final question here. Someone said, we're not using IPsec with Aviatrix. What are we using to secure or protect the information being transmitted?
Yeah, so it's important to understand that the traffic that we are talking about here is between VPCs in the same region. So they are secured inside AWS premises. So from the perspective of most of the customers we talk to, really that is considered a private conversation there and does not need encryption. In fact, encryption there is just, you could call it a stopgap measure for bringing the traffic from your VPCs to the firewalls. And it's really an inefficient way of doing that.
Okay, one final question that's come in. Can you talk about scaling out using the new M5 EC2 instances as opposed to using auto-scaling groups?
So yeah, I'm not 100% clear about that. If that is the instance size of the M series, I'll let Jigar elaborate.
Yeah, can you repeat the question? I think I didn't quite understand the context.
Yeah, sure. Someone's asking if you can talk about scaling out using new M5 EC2 instances as opposed to using auto-scaling groups.
So the M5 instances can be part of auto-scaling group. I don't see a reason why they cannot be part of an auto-scaling group. If today auto-scaling is for internet-facing workloads, and so the auto-scaling can use M5 or even M4 or the older generation, there is no issue. I think the main thing you're looking for is what is the performance that M5 gives you, and do you need actually auto-scaling or not, right? Some use cases don't. So even for internet-facing workloads, you always don't need auto-scaling if you have a good idea what your capacity needs are. The performance for M5 is in that data sheet at live.paloaltonetworks.com/AWS, and then you can just see what does M5 give you. So I'm not sure if I can give you a clear guidance on that. It's essentially a performance question of what you need, and do you actually need auto-scaling or not.
Yeah, and I'll add to that, on Aviatrix gateways, we support C5 and C5N instances that basically offer the best throughput you could get out of, instances in AWS infrastructure. But,
before we wrap this,
on the side. Yeah, go ahead, sorry.
Sorry, yeah, just before we wrap this webinar up, one final question has just popped up. If we use Aviatrix, then we're letting the routing be handled by the TGW and Aviatrix, and then we let the Palo Alto do its thing. Is that right?
Yeah, I mean, I believe that's more like I believe it may be a comment there, but that is true. I mean, the idea is that we let the infrastructure, we configure the infrastructure in AWS to do what needs to be what needs to be done in order to get packets from VPC to the firewall, right? So the transit gateway route tables, the VPC route tables, and then our gateways for managing load balancing. And the VM series are sitting there basically doing what they're supposed to be doing, as I believe the comment had alluded to, and that is to inspect your traffic, do threat prevention, do threat detection, instead of doing routing or IPSec tunneling.
But the point is, if you're not using Aviatrix, then you're going to have to manually propagate these routes, and any changes that happen, you're going to have to manually configure those out to TGW, to the firewalls, out to the VPCs, right? And so this makes it very easy both to configure and to keep going from an orchestration standpoint.
Excellent. Thank you very much for taking the QAs there. There's quite a lot of questions coming, some really interesting questions and some great answers as well. So let's wrap this up. I just want to say thank you again to everyone who joined us here today, and a special thanks to our guests from both Palo Alto Networks and Aviatrix. It's been a really interesting webinar with some great content which looked at architectural design patterns, performance, and best practices on essentially how to effectively manage security across multiple VPCs at the network layer. So thank you very much, guys. If you have any final comments, then by all means jump in. But thank you.
Yep, thank you. It's been a pleasure.
Cheers, guys. Bye.
All right, bye.